This chapter is all about solving systems of equations, and we've already done this in algebra. In the warm-up that I have posted here, we solved the system in one of three different ways. We either using elimination, substitution, or by finding the point of intersection by graphing. What I want to talk about today is another way of solving a system of equations that's often used in a system of three linear equations in three variables. And that process is to rewrite the system in what's called row echelon form, or also known as triangular form, because it really just involves taking that system and rewriting it so it looks like it's in triangular form, kind of like this right triangle here. And the idea behind row echelon form, or what I will say as REF for short, is simply a system in which now you've rewritten it so the first row has all three variables, the second row has just y and z, and the final row has z. And what we want is a coefficient of 1 in all three of these rows, a leading coefficient of 1. So this process of writing this in row echelon form is what is known as Gaussian elimination, developed by this really smart mathematician named Carl Friedrich Gauss. And we'll talk about him a little bit more in the next chapter, but for now, let's focus on taking a system and writing it in row echelon form. Now, before we go through this process, I want to make sure we understand what the benefit is of taking a system that looks like this and writing it in row echelon form. And that simply is because once we get it into REF, we can do a process called back substitution, which is exactly what it sounds like. It means we're going to take this final row here where z is equal to 2, and we're going to substitute it back into this previous row. So we would say y plus 4 times 2 is equal to 7, and y is equal to negative 1. Now we know what z and y are. We're going to go ahead and find what x is. So we're going to say x minus 2 times negative 1 plus 3 times 2 is equal to 9. And that means x should be equal to 1. So our solution would be x is equal to 1, y is equal to negative 1, and z is equal to 2. And just like we wrote a system of equations solution as an ordered pair in the warm-up, we're going to go ahead and write this solution as what we call an ordered triple, where this would be 1, negative 1, and 2, where it's implied that the first value here represents its x, this is the y, and this is the z value here. So the benefit of writing a system in REF is so that we can do back substitution to find the unique solution that satisfies all three equations. So this process of going into row echelon form is known as Gaussian elimination. And this follows what we call a series of row operations. So the first thing that I'm going to do here in this example is I'm going to rewrite this. And the reason why I'm rewriting this here is because I noticed that my second row here is a really good candidate to be my first row. So I'm just going to rewrite this so that becomes my new row 1. In other words, this would be x plus y plus z is equal to 6. And I'm going to just take my row 2, or excuse me, my original row 1 and make it my new row 2. So this would be 2x plus y plus z, excuse me, 2x plus minus y, 2x minus y plus z is equal to 3. And I'm going to keep my row 3 the same. So 3x plus y minus z is equal to 2. Now, why do I want my row 1 to have a leading coefficient of 1? Because you're going to see in a moment that it's going to make my life a whole lot easier when I need to try to eliminate the other values here. So I can just rewrite my system as I have it here, but this is a good time for me to introduce a way that I'm going to write my row operations. So what I just did was switch around my original row 1 and row 2. So one way that I can indicate that is I put 1 with a circle around it to indicate that it's row 1. And I'm just going to use this notation to indicate that I switched row 1 and row 2. And this is really important. The result of my row operation is what I'm writing in my system to the side. The result of my row operation is what's written there. So you didn't have to do that particular row operation. You could have just worked with it as it was, but I think it's going to make my life easier now. So let's go ahead and start rewriting. So I've got my first row 1. That looks great. That has exactly what we need, a leading coefficient of 1, all three variables. So that's pretty much locked in and ready to go. I now notice again, our goal is to get this into row echelon form, into REF, which means in REF, I need a 0 here and zeros here. So what that means for us in what we have is I need to eliminate, using elimination, I need to eliminate this first term of 2x. Well, ask yourself, how can I use some of my other rows to eliminate that 2x? Well, I can multiply row 1 by negative 2. So row 1 by negative 2, let me write it as such. So I'm multiplying row 1 by negative 2, and then I'm adding it to row 2. So this is just elimination here. So I'm going to multiply this row here, this first row, by negative 2. Now, when you are doing this, you can do this mentally. You can also, and I often recommend using some scratch work off to the side. So I'm going to label this as scratch work. And I'm going to do this where I'm going to now multiply row 1 by negative 2, which is negative 2x minus 2y minus 2z is equal to negative 12. And I'm going to add that to my second row. So 2x minus y plus z is equal to 3. When I add these two rows together, what do I get? Negative 3y minus z is equal to negative 9. Okay? Now, I want to really emphasize when you are doing your scratch work, do it off to the side. Don't incorporate it into your row operations. That makes it virtually impossible for me to evaluate, or any reader for that matter. So you want to do this off to the side. I will not ever be grading your scratch work. In fact, you can do it on a separate sheet of paper. What I care about are your row operations and making sure that you have an accurate result of your row operation right next to it. So for example, this operation here, this negative 3y minus z equals negative 9, I'm going to write that result. The result of my row operation goes here. So I'm going to leave that there. Again, do your scratch work off to the side, having it labeled, do it on a separate sheet of paper. You can even do it mentally, right, or in your head. What I don't want you to do is start doing that work or incorporating that work in between your row operations. That makes it incredibly difficult to read. So now let's move on to eliminating my next value. I want to eliminate that 3x there. So I'm going to do something pretty similar. I'm going to multiply my row 1 by negative 3, and I'm going to add that to row 3. So row 1 by negative 3, and I'm going to add that to 3. So again, you can do this mentally if you want, or you can write out the scratch work. So I would say negative 3x minus 3y minus 3z is equal to negative 18. Now I'm going to add that to my row 3. 3x plus y minus z is equal to 2. If I add that all up, I'm left with negative 2y minus 4z is equal to negative 16. Now you'll notice here that when I did this, I notice I have a common factor of negative 2 in all of my terms. So if this were just an equation that I were solving and I wanted to simplify, I could divide everything here by negative 2. And that would give me y plus 4z is equal to positive 8. So I can actually write this result here. So y plus 4z is equal to positive 8. And what that just means is in my row operation, let me actually make a little bit of space. In my row operation here, just move that over, I want to make sure that I indicated that I divided everything by negative 2, which is equivalent to multiplying all of this by negative 1/2. So I did my row operation, I multiplied it by negative 1/2, and the result of my row operation is what we have here. Okay, so let's take a look at what we have so far. So we're pretty close to having this in row echelon form. All I need to do next is I now need to eliminate this y, and then I need to worry about getting those leading coefficients of 1. So let's move on to the next step. So again, my first row was good. X plus y plus z is equal to 6. This row 2, in order to get this with a leading coefficient of 1, I just need to divide everything here by negative 3. So I'm going to say I'm going to multiply row 2 now by negative 1/3, which is equivalent to dividing it by negative 3. And now what we're left with, if this is y, this would be positive 1/3 z, and this would then be positive 3. So this is equivalent to me dividing everything here by negative 3. Now to eliminate this y in my row 3, I'm looking here now at this row 3, to eliminate this y, I can then go ahead and I'm working with my previous row 2. So I'm still looking at this row 2 in order for me to change this row 3 here. So what that means is I can multiply my previous row 3 by 3 and add it to row 2. So I'm going to rewrite it as such. I'm going to take this here. So again, I can zoom out here and eliminate my scratch work if I want to. I'll just go ahead and erase this as well. So again, I could do this with my scratch work. I can say, all right, so this would be negative 3y minus z is equal to negative 9. This is 3y plus 12z is equal to 24. And then I would write this here as the following. So we have this here as 11z is equal to 15. And did I make a mistake somewhere? Not quite sure. Y plus, I may have made a mistake in my previous step. If I went ahead and I multiplied negative 3 times row 1 plus row 3, let's look at my previous step here. This, I believe, should have been, I see my mistake. I apologize. This should have been 2z here. There we go. So I guess it's a validation that it's a good idea to make sure that you show your scratch work clearly instead of all trying to do that all in your head. I think when I divided there, I forgot to clean that up. So if that's the case, then that's going to make my row 3 times 3. So that should have been 6. Here, this should be 6, which would make this 5. And I knew that I was on the wrong path because I don't remember me getting fractions for this problem. So that would give me 5z is equal to 15, in which case I can then simplify that, divide everything by 5, and make z is equal to 3. So here now, I'm going to go ahead and write that I divided everything by 5, and I write that result. Z is equal to 3. So now that I have that, I have my system in REF. This is row echelon form. So now that I have that, I'm now ready to do my back substitution. So let's go ahead and make some space for that. So we can say, let's do some back substitution now. Now that I know z is equal to 3, I'm going to plug z equals 3 back into my previous row. So y plus 1/3 times 3 is equal to 3. Y then is equal to 2. And x plus 2 plus what my z value is, 3 is equal to 6. X is equal to 1. Again, we shouldn't stop here. We should express our solution as an order triple. So we'd say 1, 2, 3 is our order triple. And we're done. We've solved that system. So Gaussian elimination is the process of using row operations to take our system as it's given to us and putting it into row echelon form so that we can do back substitution. Again, we don't really need to show all of our scratch work, but as I demonstrated in this problem, it's a good idea to have some scratch work done instead of trying to do everything in your head. But what I really care about is making sure that you indicate all of your row operations clearly and you're writing the results of your row operations right next to it. So hopefully this gives you a good sense of how Gaussian elimination works. And really to get better, you're just going to need to practice this a lot, take your time, and make sure that you're very careful with all of your calculations.